Taking a look at example 7 from Unit 6, Lesson 3. I'm going to break this apart for you to better understand that we're taking 3 times the quantity 1 over x squared minus 1. Like our previous example, this is a vertical shift. So this is a vertical shift. Everything is shifting down 1. If you recall from freshman year, this is going to be a vertical stretch. We're going to take the y values and multiply them by 3. So let's really focus on this. In this situation, we have y is equal to x to the 0 over x squared. And so if I focus in on the degrees, I can see the degree on top is less than the degree in the bottom. And so I'll have a horizontal asymptote if y equals 0. So I'm going to do that right on my paper at this time. So I've identified that the horizontal, I want to make sure that this stands out to us. I've identified that the horizontal asymptote is y equals 0, based on the degree in the numerator and denominator. If we come back to this and we look, we see we do have, there's no way for us to reduce this fraction, and we do have a variable in the denominator. When I set that equal to 0, I'm able to solve. And although we normally say plus or minus, there's no such thing as plus or minus 0. There's simply 0. So the vertical asymptote will occur at x equals 0. As a reminder, our functions will never cross or intersect the vertical asymptote, and generally they don't cross the horizontal asymptote. If it's going to happen, it's going to happen in the middle of the graphs, definitely not on the ends of the graphs. So this is a pretty easy one for us to get started with. Let's just do this. We know at the very end we're going to shift it down 1. So this line is going to be shifted down to here. Everything's going to be shifted down 1. Let's just get started here. And what I want us to focus on is this function. So with this function, if I input in, now we can't input in 0 because 0 is going to be our vertical asymptote, but we can do -2, -1, we can't do 0, 1 and 2. You can see if I plugged in 0, to get 0 in the bottom of a denominator, it's not possible to evaluate. So -2, well -2 squared is 4, and I end up with 1/4. -1 squared is 1, 1 divided by 1 is 1. 1 squared is 1, 1 divided by 1 is 1, and 2 squared is 4, 1 divided by 1 is 1/4. So if I think of this graph, normally, without us shifting it, I haven't even brought up the 3 yet, without us shifting it down, I would take these points, again, this is if I excluded the 3 and the -1. It's like I forgot about those. And this is what it would look like. It would say, hey, don't cross the x-axis or the y-axis because they represent the vertical and the horizontal shifts. And I'd graph these points. So I'd go +1 and up 1 and +2 and up 1/4. -1 up 1 and -2 up 1/4. So it's looking just like this. Now from this, we do need to translate this. What do we need to do? Well, the easy one is we're going to shift everything down 1. That will be pretty easy. What does this 3 do? When we say that it vertically stretches it, it means it's going to rise at a faster rate. 3 times we're vertically stretching it. So I take this 3 and I'm going to multiply it by each one of these quantities. So 3 times 1/4, well 3 times 1 is 3, and then 3 divided by 4 cannot simplify. 3, we're multiplying times the y's, times 1 is 3, 3 times 1 is 3, and again 3/4. So this is what I'm looking at. These are each going to be paired up here. So I'm going to do a final sketch right now, and we'll just keep it right on this paper here. Okay, so I'm going to shift down 1, and our vertical asymptote remains the same. Think of this as our new origin. Think of this as our new origin. I'm going to go over to the left 2 and up 3/4. Left 2, 1, 2, and up 3/4. I'm going to go over 1 from my origin and up 3. Over 1, up 3. 1, 2, 3. And now we're going to go 1 to the right of my new origin and up 3. 1, 2, 3. and 2 to the right of my new origin, and up 3/4. And this is the translated function. I've identified the horizontal asymptote, the vertical asymptote. We call these critical points. These are these important critical points that we want to see when we sketch this graph. But let's just do one more thing. We can see that we will never have a y-intercept. Nothing's ever going to cross this vertical asymptote. But it does, as you can see, it looks like we are going to have an x-intercept. So how do we identify those points? Whenever we identify the x-intercepts, y is always equal to 0. So I'm going to come over here and replace n of x, which is like y, with 0. I'm going to add 1 to the opposite side. 1 equals 3 over x squared. Remember, we can always write it as 1 over 1. And I'm going to cross multiply. I have 1x squared equals 3, and dividing by 1 doesn't change anything. So x squared equals 3, and taking the square root. That means that my x-intercepts are x equals positive square root of 3 and negative square root of 3. So this will occur right here, positive and negative square root of 3. Okay, it's your turn now. Please go to problem number 7 in the homework and complete it.